Hi, my name is Alan Jake Plaintan, and today we're going to be building an electric motor. What is a motor? So a motor is a machine that turns electrical energy into mechanical energy. Examples of a motor include a blender, a washer, a hair dryer, a fan, microwaves, and more. Okay, so what we use to create the motor is a battery, two paper clips, two rubber bands, a varnished magnet wire, aka the coil, sandpaper, and a magnet. So we use a battery to supply the electrical energy, allowing a current to flow. We use two paper clips to act as conductors, which are in the positive and which are connected to the positive and lower terminals of the battery. The clips were also used to extend the height of the coil so it won't touch the magnet. We adjusted the paper clip's height a bit so we could do that. We used two rubber bands to secure the paper clips. We used the coil to serve as something to spin, and it had some magnetic properties, so it also provided the opposite charges, allowing the coil itself to spin. We use a sandpaper to remove the insulation from one of the coil's sides, and finally we use a magnet to provide a magnetic field. So some modifications we did is changing the coil to form a circle so it wouldn't touch the magnet. Also just look cleaner. So we bent the paper clips so it would give the coil more balance. We sanded only one side of the wire on one end of the coil so it would allow the field to turn off. And making it off and on would allow the coil to spin due to opposite charges. Finally, we gave the coil a little spin, a touch, to get it going.
If you want to use tools, remember you're using the tools up here. You're welcome to use the tools, but don't bring them back to your
Alright, Tyrese.
So now I'm gonna explain why all of this works. Since we know that a current flows from the positive to negative, which goes to the right, we can use the right hand rule to figure out the direction of the magnetic field. When I pointed my thumb to the right, where the current was, my fingers curled in a counterclockwise position, a direction. This told me that the magnetic field went counterclockwise. If we reverse the current, it would go clockwise. The field is on when the current is on, with a magnet underneath. When both ends of the coil, without the side with the insulation, touch the paper clips. The field is off when there is no magnet or when the current is off. Also, the field could turn off when the insulation from one end of the coil, or the one side of the coil from the end of the coil, shuts the current off. It is important for a field to turn off and on, as it allows the motor to spin and work. If it was on all the time, it would turn for a bit and eventually stop. In the other case, having it both on and off will allow it to spin. It works because when the current is on, it creates a magnetic field forming the north and south pole. As we know, opposite charges attract, making it go to the magnet, causing it to spin. The current then turns off when the paper clips touches the insulation side of the coil, which is in the end of one side of the coil. The, However, the coil is still spinning, and there's still momentum from when the current was turned on. So when it goes to another cycle, the current will turn on again, then it will turn off, but the momentum keeps going on, allowing the current to keep a continuous circular movement. So let's start off when it was not energized. So in a not energized one, we have a force normal going from the paper clip to the coil, and the force gravity coming from the earth to the coil. And the in this case, since the coil wasn't moving, the forces are balanced. And for when it was energized, the forces are similar to the last force diagram, except this time it has magnetic forces that allow the coil to spin. Since the coil is spinning constantly, the forces are still balanced, and the magnetic forces are affecting the coil. This brings us to the end of my video. So I'd like to give credits to Hannah and Fabi for helping me construct Moter, and the rest of the work goes to me since I basically work alone, but I just work with my group mates in the actual creation of it. So I'll thank you for watching, and goodbye.